Hey y'all. So I may not be 100% myself today because I got some worries today. And I know some of y'all have shared some of your challenges with me. So I know, we're all in the same boat. Part of our part of our thing that we want to accomplish at Helms is to make sure that you have a real instructor who's really communicating with you and really here. So I'm just going to be real about that today is a little bit of a off day for me, and it's harder to rally when I don't really have y'all right in front of me. But anyway, so we're going to get through this today, and I think there's so many things about plants that are really interesting, and I hope you're going to think this is really, really interesting and start seeing how all of this kind of comes together. We're going to talk about light, some rules of thumb with light. So whether you decide to get really, really into growing your own plants, or whether you just have plants in your home, I think you're going to appreciate this. So let's talk about some rules of thumb with light. So first I want to do a couple review questions. What is a stoma? Or plural would be stomata. What's a stoma? So I hope you remember this. Stoma is a hole in the leaf, usually on the bottom epidermis, that actually opens when the conditions are humid and light, usually, or nature will find a way sometimes, but they usually open when it's humid and light, and it lets in carbon dioxide for photosynthesis. What is the cells that surrounds the stoma that actually open the stoma? I hope you said guard cells. If you said guard cells, you're absolutely correct. So we won't get into the whole way that it works, but guard cells actually, what happens is they get full of potassium, which is scientifically a salt. And if you've ever poured salt on a table and left it there, I don't know, maybe as a kid you did that, and if you come back, the salt's damp. It's attracted water. So salts actually attract water. So when the guard cells get full of potassium through a whole nother system that we're not really going to get into, they then attract water. The water goes into the guard cells and fills them up and makes them make a hole, open the stoma. All right, so colors of light on the light spectrum that are collected by the chloroplast for photosynthesis. What do you remember? I hope you said red and blue. Red and blue are your colors for photosynthesis. Chloroplast, the chloroplasts that collect the light for photosynthesis and do so much of our photosynthesis process. Where are the chloroplasts located? Don't just give me the easy answer of saying the leaves. What part of the leaves? And I hope you remember the mesophyll layer. Mesophyll layer. So we have the mesophyll layer, we have the epidermis, and the epidermis is covered by a waxy layer that can be different thicknesses depending on the needs of your plant. But that waxy layer that protects the plant is called the what? The cuticle. Hopefully you remember that from chapter 2. So anyway, after we've reviewed all that, let's go over some rules of thumb. So if you have a plant that has darker leaves versus lighter green leaves, dark green versus light green, which one is going to have the most chloroplasts? So because chloroplasts reflect the green light, which is what we see, the one that has the darker leaves are going to have the most chloroplasts. So if it has the most chloroplasts, can it collect more light or less light? It can collect more light. Therefore, you don't have to compensate with more light to give it what it needs, all right? So the one that has the lighter colored leaves, it can't collect as much light. Therefore, you have to compensate by giving it more light to give it what it needs. So the darker can go in a lower light area, and the lighter leaves need a higher light area. So if you have two plants, let's look at your worksheet that hopefully y'all did download or look at. Let's say if you've got, well, it's not really a good example on here, but here's two rubber tree plants. So you've got one that's very dark and one that's a little bit lighter. So if you've got two plants, one with lighter leaves and one with darker leaves, and you've only got one window to put a plant by, which one are you going to put by the window? You're going to put that one that it has the lighter green leaves by the window. All right, so another rule of thumb, variegated versus non-variegated. So there are some good examples of that on here. So on your sheet, if you go all the way to the bottom and you look at the wandering Jew plant, and you look at the coleus, and you even look over here at the philodendron, you will see that some of these leaves have colors on them other than green. All right, they have some red, they have some light streaks, some yellowy streaks, some purple streaks. So all of those places that are not green are places that don't have many chloroplasts. So if you have a variegated leaf, you're going to have less chloroplasts. If you have less chloroplasts, you can only take in less light. Therefore, you have to compensate by being in a higher light area. So if you're variegated, then you need high light. So this is going to be a highlight area versus non-variegated. The non-variegated is going to have lots and lots of green area, therefore lots and lots of chloroplasts to collect light. Therefore, you don't have to compensate with a higher light. You can just use a lower light area. So if you look at your page here, you will see the philodendrons is a good example. You've got some of the cultivars or varieties. Remember, a cultivar or a variety is a plant that's in the same species but has unique characteristics to that species. So you've got some that are just all green leaves. The green leaves are all green, and some that have some variegation. So if you have two of those, you'll know which one needs to be by the window or which one needs to be by the, the higher light area, and which one you can put up on the fridge where it's not going to get as much light. Thicker cuticle versus a flatter leaf. So if you have a fat little leaf, like if you look on your paper, like a kalanchoe or a jade plant, those have a thicker cuticle. Now, first of all, why do they have a thicker cuticle? Most likely that has been an adaptation of their environment where they've had a lot of sun. So they have a thick cuticle to keep, they don't want a lot of water to evaporate. So the cuticle keeps that from happening, makes it have a lower transpiration. And also it's just going to build up in response to the sun to protect the leaf. So if they have a really thick cuticle, there's my fat little leaf. That's a side view. Okay. And here's the sun coming down on it. Well, our chloroplasts are in the mesophyll layer right here in the middle. So the sun has to get through the cuticle and the epidermis and get down to hit the mesophyll layer. So the sun has to get through a thicker area, then you're going to need more light. You're going to have to compensate with more light. So if you have a thicker cuticle, a thicker, fatter leaf, you need a higher light. And then it's a circle. In response to that higher light, that plant has adapted a thicker cuticle. If you have a flat leaf, and if you look down here on the bottom arrowhead, that's a natural plant, that outdoorsy wild plant that grows a lot of times in wetter areas. So it's hydrophilic. And also it grows in shady areas. So anyway, if you look at that, it's a really big flat leaf. So if you have a flat leaf and the sun's hitting it, it does not have very far to go before it hits that mesophyll layer. So if you have a flatter leaf, you can have a lower light. So I hope you enjoy those rules of thumbs on plants, and now you can go through your house and check to see if all your plants are in the right place. So have a great day, and I'll see you next video.